Alright, so today what we're going to be learning is kind of a review of stuff that we've already learned. It's just kind of taking it one step higher, looking at some bigger exponents. But we're multiplying monomials by polynomials. So the first thing that we have to understand is what makes something a monomial, a binomial, a trinomial. And that depends on how many terms are in it. So when you are in biology or another science class, you've probably learned a lot of prefix words. So if you have the word mono, think about what does that mean. Mono means one, so a monomial, and you'll fill this in on your notes as we go. A monomial means one term. A binomial, bi means two, so a binomial has two terms. And tri means three, so that is three terms. Now collectively, we call all of these polynomials because a polynomial, poly means many, right? So polynomials just means many. So anything, anytime we're talking about a polynomial in general, that just means it could be one term, it could be two, it could be three, it could be more than three. All right, so monomial, binomial, trinomial tells you how many terms. Now, in that same sense, we need to understand what the word term means. And so I want you to take a highlighter, and up here there's the definition for a term. So a term could be a number. So there's an example there, just 5 is a number. It could be just a variable, like the letter y, or it can be a combination of numbers and variables that are multiplied together. So this example is -3 times x times y, so -3xy. It's a combination of numbers and variables multiplied together. So to tell if something is one term or two terms or three terms, they're going to be separated by a plus sign and a minus sign. And so that's really important. That's how you know how many terms there actually are. All right, so we're just going to look at a few examples to give you a better idea, see it visually. So a monomial, we said, has one term. So the first example here, 6p. There's no plus or minus sign separating it, so it's just 6p. Another example is just y, or -2x squared. That's a number and a variable multiplied together. 4xyz. And then I want you to write in 2 additional monomials. So just make up any monomials you want to. It just has one term. And write it in those 2 boxes. My example that I'm going to use is 3m and -2xyz p. I can do whatever I want to as long as I don't have any plus or minus signs. Okay, so a binomial is going to be 2 terms and it's separated by a plus or a minus sign. So notice here's a plus sign in between the 2 terms. So 3p is one term, and the letter or the number 1 is another term. So they're separated by a plus sign. So 3p plus 1 is a binomial. The next example, 7a minus 4, separated by a minus sign. So 7a is the first term. The second term is 4. So that's 2 terms. 3x to the third plus x squared, we're separated by that plus sign. A plus b, we're separated by that plus sign. So now, same thing that we did on the other column, I want you to make 2 binomials. Just make up 2 binomials and write those on your paper. All right, so you could have come up with whatever you wanted to, but I'm just going to make one up and do -p minus 3x, whatever. And then you make up another one. I'm going to do a plus sign to separate it this time. I'll do 4 plus 2y. All right, so now trinomial is 3 terms. So now we need 3 different things that are 3 different terms that are separated by a plus or a minus sign. So here's the first term, x squared, separated by the plus sign. 7x is the second term, separated by a plus sign. 10 is the third term. All right, and there's a couple more examples there for you. And same thing, I want you to try and write 2 more trinomials. All right, so once you've got all of those and understand the difference between the polynomials, we're going to look at actually multiplying them. And so this is where it's kind of a review, is all we're doing really is distributing. But we have a lot of variables involved, and we're going to start off easier, but then get to some that have bigger exponents. And for the most part, we haven't done a whole lot of multiplying a variable times a variable. So today, when you multiply like variables, meaning if I'm multiplying an a and an a, you are going to add the exponents. And I'll explain why in just a second. But make sure that the two variables are the same. I can't multiply a times b and add those exponents because a and b are not the same letter, not the same variable. Okay? And here's the reason we're going to add the exponents. I'm just going to give you an example and we're going to expand it. If I have a to the fourth times a squared, okay? The reason we want to add the exponents, if I expand this, a to the fourth is really 4 a's being multiplied together, correct? Times 2 more a's. And I'm going to do this in a different color to separate it. So my a squared's going to be in pink. So a times a. So now how many a's are really being multiplied together here? It's really 1, 2, 3, 4, 5, 6 a's, right? So it's 6 a's being multiplied, which we can write as a to the sixth. So notice, if all I had to know was that I'm going to add those exponents, 4 plus 2 is 6. So that's why we add the exponents when we multiply, okay? And you could always expand it out like that every time. It's just, that would take a long time. So just get in the habit of knowing that when you're adding, you add or when you're multiplying, you add the exponents. Okay, so let's get to the first example. We have a times 4a plus 3. So if I am multiplying, I'm going to distribute like we said. What number is really in front of this a? There's really a 1 there, correct? And so I'm going to multiply 1a times 4a. So to start off with, just multiply your coefficients, which are just the numbers. So what is 1 times 4? That's just 4. Now, I'm also multiplying a times a. And if there is no exponent there, that means there's just 1a there. So I'm just going to say it's just 1a, so I'm going to put a little exponent of 1. So a times a, if I add 1 plus 1, if I add its exponents, that's really a squared. So a times a is a squared. So I've multiplied 1a times 4a to get 4a squared. Then I multiply 1a times 3. So the 1 times 3 is a positive 3, so I need to put that plus sign there, plus 3. And then the 3 didn't have an a, but I'm distributing an a over there to it, so I need to pull this a with it. So 1a times 3 is 3a. Now look at what we have left here. We have 4a squared plus 3a. Can I do anything else to this? The answer is no, because these are not like terms. Yes, they both have an a, but in order to be a like term, if you can remember from way back when, like the first week of school, in order to be a like term, they have to have the same variable and the same exponent. So since they don't both have a squared, then we cannot add them. All right, look at example 2 over here to the right. We have 7c times all of this stuff in parentheses, 5 minus 2c squared plus c to the third. So we're going to distribute. So again, we're going to multiply 7c times 5. 7 times 5, 35, and I'm distributing that c with it, so the c comes. Remember that c is an exponent of 1, but I'm not multiplying it by another c when I'm multiplying those two terms. So now, I'm going to distribute 7c times negative 2c squared. Remember that minus sign, we treat that as a negative 2. So first multiply your coefficients, which are just the numbers. 7 times negative 2 is negative 14. And then we're going to add our exponents with our c's. So out here I had c to the first power outside the parentheses, and I'm multiplying it times c squared. So if I add the exponents, 1 plus 2 gives me 3. So c to the third. And then finally, I need to distribute this last bit. 7c times c to the third. Well, c to the third is like 1c to the third. So 7 times 1 is 7. And then c to the first times c to the third. Add 1 plus 3. That gives me c to the fourth. So now let's look. Do we have any like terms in this? We do not. They all have a c, but they don't all have, none of them have the same exponent, so they're all different. So we have our simplified answer right there. All right, example 3. We're going to distribute. We're going to go a little bit faster here on this one. I'm going to distribute 3 times. So negative 3n squared times negative 2n squared. Negative 3 times negative 2 is a positive 6. N squared times n squared. 2 plus 2, 4. So I have 6n to the fourth. Negative 3n squared times a positive 3n. Negative 3 times 3 is negative 9. N squared times, remember that's n to the first, is n to the third. 2 plus 1 is 3. And finally, negative 3n squared times 4. Negative 3 times 4 is negative 12. And then the 4 didn't have any n's, but I'm distributing an n squared to that term. So I need to pull that over with it. Once again, no like terms because they all have different exponents. So that's all we can do there. All right, and the final example is going to be a little bit different because we have 2 sets of parentheses. So how many times do we need to distribute? We need to distribute twice. So I'm going to distribute this one first. So 3m times 3m. 3 times 3 is 9. M times m, remember those have exponents of 1. That becomes m squared. 1 plus 1 is 2. Then 3m times 6. 3 times 6 is 18. And I'm distributing that m to it, so it's got to come with it. All right, so that was the first set of parentheses. So the second set of parentheses, I'm going to distribute a negative 3. So negative 3 times m squared is negative 3m squared. Negative 3 times 4m, negative 12m. And negative 3 times negative 3, just 2 numbers being multiplied, no variables, is just 9. So now look at everything that we have. Do we have any like terms this time? This has m squared, right? 9m squared. I have another m squared right here, which means these 2 are like terms, so I can add them together. So, like terms, you only add the coefficients. The reason you can add them is because they have the same variable and the same exponent. So 9 plus negative 3 tells me I have 6 of those m squareds. Okay? Don't change the exponent when you combine like terms. And then I have an 18m and a negative 12m that are like terms. So 18 plus negative 12 is a positive 6. So I have 6 of just the m with no exponent other than 1. And then finally I had that plus 9. There was no like terms with that, so I just dropped that one down. So this right here is our final answer. Okay, so biggest thing, when you're multiplying, you add the exponents. When you're adding, you just add the coefficients. And that is it.